Hello, I'm going to go over the Friday assignment, the Jamboard you're doing, where you're writing rules, and I'm going to do groupings 3 and 4 in this video. All right, grouping 3, and I've zoomed in so you can see it a little bit better. Um, we always are asking you, what do you notice? What do you wonder? Well, when I look at this, I notice that both of these have parentheses. So that's the rule that I'm writing about, is that these have parentheses. When you have exponents outside of the parentheses, you keep the base the same and you multiply the exponents. So you can pause the video here if you need to write that down on your own Jamboard. What I'd love is for you to write down my words as your first draft and then try rewriting it in your own words for the second draft. Okay, so you can pause it and do that. So why does that work? Here we're going to show with math, with calculations, that this works. So we go back to that old rule of, well, what does this mean? This means 10 to the power of 3 times itself 4 times. 10 to the power of 3 times itself 4 times. So if I write that out, 10 to the power of 3 multiplied 4 times, now I have to use the old rule that we did in a previous grouping, where when the bases are the same, I keep that base and I add the exponents, 3, 6, 9, 12. So oftentimes we're using another rule to prove one of these. Okay, so I just wrote it out of what that means. I can show this one as well. So this means 10 to the power of 1 5 times. 1, 2, 3, 4. You can see why they invented exponents, right? Because this takes forever to write out. All right, let me make sure I got everything in there. So I've got 10 to the power of 1 5 times. Some of that's a little messy. Sorry, there's like an extra little piece right here that I don't want you to think it's a negative. All right, so again, let's use that old rule to prove this. Well, we were saying 3 times 4 gives us the 12, and we proved it here why it works. Now we're saying 1 times 5 equals 5. Well, if we use the old rule, let's add up 1, 2, 3, 4, 5. So I don't know if you're seeing, but this is connected to that idea that multiplication is the same as repeated addition. So we've seen that in math over and over again. All right, you can pause it here if you need to, but I'm going to go ahead and go on to grouping number 4. Wow, negative exponents get to be a little bit of a mind bender. But the rule is, when you have a negative exponent, you can rewrite it as 1 over the positive version of that exponent. So our numerator becomes a positive version down in the denominator. Let's show how this works. Again, you can pause it at any time to write down the first draft and then try writing it in your own words for the second draft. So I have some little notes here that I wrote for myself. Let's use an old rule to try to prove this. So we've got 10 to the negative 2. If our old rule, and we want the 10 to end up down on the bottom and the denominator. So I'm thinking, let's put a 10 here and a 10 here. And let's think, in some lessons, we had to create expressions that would give us this simplified version. And I know if I have division, my top number minus my bottom number will give me this exponent. So something minus something gives me negative 2. Well, I'm just going to go ahead and use 0 and 2. 0 minus 2 is negative 2, right? So I'm just rewriting this as a fraction. 10 to the power of negative 2. If this rule is true, which we proved earlier that it is, then 0 minus 2 gives us negative 2. Well, we have another rule that we just learned as well. Anything to the power of 0 is 1. Anything to the power of 0 is 1, right? So I can rewrite this again as 1 over 10 to the power of 2. And that's what we were looking for right up here. So by using two other rules that we know, the rules of division and that anything to the power of 0 is 1, I can show the steps of how I'd get there. All right. I have made a video for groupings 5 and 6. If you need to see that as well, you can look for the link to that video.